Juno's new mission, Intercepting 3I Atlas, an interstellar visitor. Imagine the thrill of intercepting an interstellar visitor. The object known as 3I Atlas, which was first identified on July 1st, 2025, is set to make a close approach to Jupiter, coming within 53.6 million kilometers of the giant planet on March 16, 2026. This event presents a unique opportunity for the Juno spacecraft, which has been diligently studying Jupiter since its arrival in 2016. In a recent paper I co-authored with the talented Adam Hibbard and Adam Crowell, we explore how a thrust of 2.675 kilometers per second applied on September 14, 2025, could enable Juno to shift from its current orbit around Jupiter to intercept the path of 3I Atlas. This maneuver could allow Juno to gather invaluable data about this interstellar object, enhancing our understanding of its composition and characteristics. Juno, named after the Roman goddess who is both the wife and sister of Jupiter, was launched from Cape Canaveral on August 5, 2011. It entered a polar orbit around Jupiter on July 5, 2016, with the mission of conducting detailed scientific measurements of the planet's composition, gravitational field, magnetic field, and polar magnetosphere. Initially, Juno was slated for a controlled deorbit into Jupiter's atmosphere, but plans have since changed, allowing it to continue its exploration. The upcoming close encounter with 3I Atlas offers a rare chance to redirect Juno's trajectory to intercept this interstellar object. Equipped with a suite of sophisticated instruments, including a near-infrared spectrometer, magnetometer, microwave radiometer, gravity science instrument, energetic particle detector, radio and plasma wave sensor, UV spectrograph, and a visible light camera/telescope, Juno is well prepared to investigate 3I Atlas up close. Our research utilizes the Optimum Interplanetary Trajectory software, OITS, developed by Adam Hibbard, which is designed to solve the Lambert problem for a single orbital cycle. This software determines the two possible orbital arcs connecting 2 points in time, allowing us to identify the most efficient path for Juno. By iterating through various trial values for the initial and final times, OITS helps us converge on the solution that requires the least amount of velocity change, or delta V. We focused on a flyby intercept rather than a rendezvous, as matching the high hyperbolic speed of 3I Atlas, 65.9 kilometers per second relative to Jupiter, would be impractical. Our calculations indicate that the Juno spacecraft has a window for applying the necessary delta V from now until the mission's anticipated conclusion in September 2025. The success of this intercept mission hinges on the amount of fuel available in Juno's propulsion system. Historical data from the beginning of Juno's mission suggests that it has a total delta V of 2.74 kilometers per second, which is strikingly close to the 2.675 kilometers per second needed to reach 3I Atlas. Although Juno's engines have not been used since 2017, this required thrust may still fall within the spacecraft's operational capabilities. If feasible, Juno could approach 3I Atlas and utilize its instruments to analyze the interstellar object and any surrounding gas or dust clouds. Our findings suggest that by applying a thrust of 2.6755 kilometers per second on September 9, 2025, Juno could successfully alter its orbit to intercept 3I Atlas. This flyby would allow for a more detailed examination of the object than what is possible with Earth-based telescopes. The thrust required for this maneuver is part of a Jupiter-Oberth maneuver, which necessitates a velocity change just 8 days before Juno's planned atmospheric plunge. After reducing Juno's altitude, an additional delta V will be applied, leading to the intercept of 3I Atlas on March 14, 2026. In total, the mission would utilize an overall delta V of 2.1574 plus 0.5181 equals 2.6755 kilometers per second. If this ambitious goal is achievable, it would not only revitalize Juno's mission, but also extend its scientific contributions well beyond March 14th, 2026. However, minor adjustments to Juno's trajectory may be necessary if 3I Atlas exhibits increased cometary activity as it approaches the Sun, which could alter its expected path. Looking ahead, the Veracruz Rubin Observatory in Chile is anticipated to discover new interstellar objects every few months over the next decade. This approach could be replicated with other spacecraft that find themselves near similar paths. What do you think? Is it feasible for Juno to intercept 3I Atlas? Join the conversation in the comments below. Could NASA's Juno spacecraft intercept an alien probe? 3I Atlas explained. Imagine a scenario where a mysterious object from the depths of space is hurtling toward our solar system. Earlier this month, astronomers made a remarkable discovery. A strange object is racing toward the inner solar system, originating from beyond our star system. This event is incredibly rare, as it marks only the third confirmed interstellar object to enter our solar system, with all three being identified since 2017. Avi Loeb, a Harvard astronomer known for his interest in extraterrestrial life, quickly proposed an intriguing, albeit speculative, theory. He suggested that this object, named 3I Atlas, might actually be an alien probe sent by an intelligent civilization. But here's where it gets controversial. Could we actually intercept this object to test Loeb's hypothesis? In a fascinating twist, reminiscent of Stanley Kubrick's iconic film 2001: A Space Odyssey, Loeb has put forth a proposal that involves utilizing an existing NASA spacecraft to intercept the path of 3I Atlas. In a paper that has yet to undergo peer review, he argues that NASA's Juno spacecraft, which was launched in 2011, with the mission of studying Jupiter, could potentially come alarmingly close to 3I Atlas by March 14, 2026. To achieve this, Juno would need to execute a thrust of 1.66 miles per second on September 14, 2025, according to Loeb's calculations. He noted, "The close encounter of 3I Atlas to Jupiter provides a rare opportunity to shift Juno from its current orbit around Jupiter to intercept the path of 3I Atlas at its closest approach to Jupiter." While this wouldn't be a traditional rendezvous, due to the object's exceptionally high hyperbolic speed, Loeb believes that Juno's scientific instruments could still be employed to gather valuable data about 3I Atlas from a close distance. However, a significant question looms. Does Juno have enough fuel left after 14 years in space to pull off such a daring maneuver? Loeb remains optimistic, suggesting that this mission could rejuvenate Juno's mission and extend its scientific lifespan beyond the potential intercept, which is just 8 months away. As scientists continue to unravel the mysteries surrounding 3I Atlas, the recently inaugurated Veracruz Rubin Observatory in Chile has provided new insights. Their observations revealed that this object is approximately 7 miles wide, making it the largest interstellar object ever detected. The prevailing theory among scientists is that 3I Atlas is a comet, supported by earlier observations indicating that its coma, a cloud of ice, dust, and gas surrounding it, could be as large as 15 miles across. The findings from the Veracruz Rubin Observatory also indicated significant amounts of dust and water ice enveloping its solid core, further reinforcing the idea that it is indeed a comet. Yet, many questions about its origins remain unanswered. Some researchers speculate that it may have originated from our galaxy's thick disk, a dense region containing chemically distinct star populations. Others propose that it could be between 3 to 11 billion years old, potentially dating back to the early formation of the Milky Way. While it seems unlikely that NASA will find Loeb's proposal compelling enough to activate Juno's thrusters for an intercept, this situation presents an extraordinary opportunity to closely observe an interstellar visitor. So, could this be the moment we finally get a closer look at an object from beyond our solar system? It's worth pondering whether the scientific community will take Loeb's calculations seriously enough to explore this possibility further. What do you think? Should we pursue this chance to investigate 3I Atlas, or is it too far-fetched? Share your thoughts in the comments. Is this interstellar comet an alien craft? Harvard scientists' bold claim explained. Imagine a mysterious object from outer space hurtling towards our solar system, and the possibility that it might not be a natural phenomenon, but an alien spacecraft. This is exactly what a Harvard scientist, Professor Avi Loeb, is suggesting, leaving the scientific community and the public fascinated and intrigued. But here's where it gets interesting. Most scientists agree that the object, known as the interstellar comet 3I Atlas, is indeed a comet. But Professor Loeb is not convinced, and his reasoning is worth exploring. As someone who has previously claimed to have seen evidence of alien life, Loeb's suspicions about the comet's origins are certainly thought-provoking. According to him, there are clear signs that this object could be an alien craft, and we should consider all possibilities before jumping to conclusions. In an interview, Loeb emphasized the importance of keeping an open mind, saying, "We should put all possibilities on the table, that it's a rock, a comet, or something else until we get the evidence, the data that will tell us what it is." The comet's unusual trajectory, which will take it close to Venus, Mars, and Jupiter, has raised eyebrows, and Loeb's team believes that its path appears to be intelligently directed. If this object is indeed alien, the implications are profound, and the world should be prepared. As Loeb puts it, "I think that when we have a blind date from a visitor from another star, all bets are off. We shouldn't assume anything, and we should assess the risk given the data that we have." To assess this risk, Loeb proposes using a scale similar to the Richter scale for earthquakes, with 0 indicating a natural object like a comet, and 10 indicating an object that maneuvers as if it has an engine, suggesting technological origins. The object is expected to pass closest to the Sun on October 29th, and while NASA assures us that it poses no threat to Earth, the possibility of it being an alien probe is a tantalizing one. And this is the part that most people miss: the sheer probability of other life forms existing in the universe. As Loeb points out, we see a lot of houses on the cosmic street that look just like ours, analogs of the Earth's sun system. And I think it's very arrogant of us to assume that they don't have residents. So what do you think? Is Professor Loeb's theory far-fetched, or is it a possibility worth considering? Should we be more open-minded about the existence of alien life and the potential for interstellar travel? Share your thoughts and let's discuss. But before we dive into the comments, let's ask ourselves, what if this object is not a comet, but a messenger from another world?